Welcome to Science versus Pseudoscience. I'm your host, Nathan Oakley, and I am joined by John, otherwise known as Quantum Eraser. First and foremost, big warm welcome to you, John. How are you doing?
Ahoy hoy.
Ahoy hoy. He's never going to live that down. He's not even going to mention, but ahoy hoy to you too, John. Good to have you.
Good to be here.
So, over the last, 8 months, science has been the most prevalent part of the discussion on flat Earth debate, and a lot of people have misapprehensions and misunderstandings about what science actually is. So, in case the title gives it away, this particular presentation is What is Science? So, maybe you can add to that for an intro, or maybe you want to jump straight into it. You tell me.
Let's just jump straight into it.
Okay, I'll get your screen presented. Give me a second.
Let me know.
Yeah, you're on.
All right. Paleontology, anthropology, archaeology, geology, evolutionary biology. Yeah, I'm still laughing. Theoretical physics, non-experimental. Astrophysics, astronomy, and cosmology. These are not frigging sciences. Okay? Crocheting is more scientific than these clowns combined. Why? The first six pretenders can't get to the first step of the scientific method, which is science, observe a phenomena without a time machine, right? And these guys, the ones in our genre, right here, well, they got some other problems. They can't formulate scientific hypotheses because they lack viable independent variables. Therefore, they can't isolate, test, and validate their dependent variables or predictions. Step 3, the scientific hypothesis step. This is a hard stop, all right? You have to be able to adhere to the scientific method if you are doing science. This isn't rocket science. Very easy. The true sciences are quantum mechanics, i.e. physics, genetics, chemistry, biochemistry, and biology. Now, with biology here, I'm talking about cellular biology, molecular biology, microbiology, not the glorified secretaries conjuring conventions. Okay? Just so we're clear on that. Now, there's a caveat with these guys also. Each claim from any of these disciplines must be accompanied by experiment, preferably repeated, validating each claim. If no experiment, then that equals codswallop horsepucky. Now, for the most part with these disciplines, you're going to get experiments. I'm not saying that every now and again that you're going to get op-ed pieces like what these guys do, right? That's all they have is opinion and editorial pieces. That's all they can do. Sometimes you'll get them with these guys also, but don't worry. You can dismiss the op-eds, but don't put up. Sorry about that.
No worries.
You can get, like I said, a lot of op-eds from the other guys, but sometimes you're going to get them from these guys also, right? But they're few and far between. If you do get them, just dismiss their op-eds, right? You don't dismiss the entire discipline or the things that are already validated by experiment. It doesn't make any sense. It's non sequitur. Like I said, if there's no experiment, that equals codswallop horsepucky. And very important, like I said, do not fallaciously indict the actual sciences, these guys, with these guys, right? We're talking two different things. Now, recently, becoming more prevalent that you have the flat earth community attacking these guys, right? Don't do that. And I'm going to tell you what, because I've been teaching on this for quite some time. And I've reached my end point. So if you're a flat earther and you come out and start attacking these with your ignorance and with the verbal diarrhea of the incoherent pie holes, I'm going to embarrass you, right? I'm taking the kid gloves off. You are fair game. You want to come out here and give your feelings and stuff, and I think in your generalized assertions, baseless variety, and what you think, and you want to attack these guys, you better have your crap together because it's over. I'm just going to embarrass you. I'm giving you that warning right now. If you want to listen to yourself talk, if you want to, give your opinions on what you think, go find some cake decorating forums, right? Or whose favorite color is the best forums, because I'm not putting up with it anymore. Flat earther, I don't care who you are, you do it, I'm going to embarrass you and treat you like the pretender clown that you are. Savvy? We can move on. Science from Michael Crichton, testimony before the U.S. Senate Committee. Science is nothing more than a method of inquiry. Nothing more, nothing less. Scientific evidence from the Law Dictionary, the testing of a hypothesis or a theory that is objective and in a controlled environment. Now, do you see any equations or models or pictures in here? Right? So when we ask for scientific evidence, do not give us these clowns. We're going to throw it right back at you. And for the semantics appeals from the bankrupt globetards. Words have precise meanings in science. This shouldn't surprise anyone. Science deals with precision and accuracy. So no more semantic appeals. They're train wrecks. Okay? Now, the scientific method. It's simply this, right? I told you before, I got this in 5th grade general science. It hasn't changed. Still the same. I've highlighted 4 of the steps. That's not to say that the others aren't important, right? I'm just not going to deal with them here today. This logically follows. We just wanted to highlight the big guys, right? Observe a natural phenomenon, literature review, construct formal scientific hypothesis, test experiment, analyze data, validate or invalidate the hypothesis, and report results. If it makes sense, it flows, right? That's all it is. We can confirm this by the University of Rochester Physics Department. It basically says the same thing I said up here. Okay? Shouldn't be any problems with this. I'm going to concentrate first on this guy. Observation and a description of a phenomena or group of phenomena. This guy right here. Step 1, right? From the Nature of Science and the Scientific Method from the Geological Society of America. The first process in the scientific method involves the observation of a phenomena, event, or a problem. So what is the first step of the scientific method? You guys getting this? Right? Observation of a phenomenon. Observation of a phenomenon. It's not ask a question. Okay? I do know where you guys are getting this from. Let's see where they're getting it from. Because as soon as we bring this up, guess what they do? Guess what the crayon munchers do, right? All they do, they're wicked Google scientists, so they put the scientific method into Google, right? Then they pull up images, and this is what they get. They pull up the first one, and it's science buddies. And what do they say? The first step is ask a question. This is incorrect, as I've just shown you, right? It's not ask a question. Like, I can ask a question. Are you a crayon munching retard? Right? That's a question. Is that available for scientific inquiry? Even though you are? No. My word, right? It's observe a phenomenon. And from Niels Bohr, no phenomenon is a phenomenon unless it is an observed phenomenon. Can't conjure something. You have to observe a phenomenon so you can formulate an actual scientific hypothesis. The whole point. I hope this is clear. It's probably not. I've given this presentation so many times. We'll get somebody on tomorrow. First up in the scientific method, ask a question. Another canard that's been coming up here the past, I would say 2 months now. It's not getting through to them because they're still trying to appeal to it. I just don't get it. So let's go over it again. So science, let's define it. The intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. Very simple, to the point. Physical and natural as opposed to non-physical and supernatural. Da, people. I mean, they're tacitly given this juxtaposition. I don't see why you can't see this. Example, can you please identify a non-physical natural for me? I'd really like to see that. Let's go over this one real slow. What is the natural world? All of the animals, plants, and other things existing in nature and not made or caused by people. I say again, the natural world. All of the animals, plants, and other things existing in nature and not made or caused by people. This is pretty cut and dry. It has definite boundaries. Physical, of or relating to or resembling material things or nature. The physical universe. So, let's just entertain it. Just for argument's sake, let's entertain the globetards argument, and we're going to allow man-made objects as natural phenomena. Excuse me, and we'll see how it shakes out. Let's see how it logically follows to its ends. From Kennesaw State, a law describes what nature does, and we're going to be talking about this here specifically in a few minutes, so just hold on. So again, a law describes what nature does. A theory explains how nature works, right? If you wanted to summarize science in 2 short statements, besides the scientific method, this is their goals, right? A theory and laws, basically, and they tell you what they are. So, having said that, are they talking about lawnmower theories and toaster oven laws? Or pendulum theories? Or is it pendulum laws? Or bowling ball theories or bowling ball laws? I'm just so overwhelmed when I go into the NCBI database and other databases. I'm overwhelmed with all these theories and laws of man-made objects. I just can't get through all of them. Unbelievable. By the way, you'd fail 5th grade general science, whoever's peddling this nonsense. Furthermore, as we'll see below, the entire goal of the scientific method is to elucidate, that is, reveal, cause and effect relationships. Well, aren't man-made objects caused by man, by definition? Why do we need them to scientifically investigate it then, if we already know the cause? I mean, I don't know. Are they mainlining fluoride? Or living under power lines? I'm not kidding this. I mean, this is basic stuff. Incoherent 2nd graders can reconcile this. Why do we continue to have to spend time here? I don't know. One of the most important statements, I've been reading this over and over again, and the more I do, the more I just stop right here. Because it speaks 1,000 words. And it destroys 99.99% of all appeals. That is, it doesn't matter whether they're flat earthers or globetards. It doesn't matter. From the University of Rochester Physics Department, the scientific method distinguishes science. That means it separates science from other forms of explanation because, here comes the punchline, of its requirement of systematic experimentation. So, if somebody says they have a scientific claim and they're without this, how then can it be science? Because I'm not following. Right? This is, like I said, I don't know. I don't know. I wish somebody would tell me. So let's go through it. Experiment, otherwise known as a hypothesis test. The experiment is your hypothesis actualized. So, and I've gone through these 1,000 times. Let's go through them real quick. From Luar's Introduction to Theory and Application of Molecular and Quantum Mechanics, the final arbiter of truth in science is experiment. From the Chair of Physics at Yale, the only way things change in physics is experiments. Everything is based on experiment. That's the only way we change our mind. From Richard Feynman, if it doesn't agree with experiment, it's wrong. And that simple statement is the key to science. From Max Planck, experiment is the only means of knowledge at our disposal. Everything else is poetry and imagination. Again, from the University of Rochester Physics Department, the scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. Experiment is supreme. Experimental verification of hypothetical predictions is absolutely necessary. So it's looking like we're going to have an experiment. If you're going to make a claim about science, you better have an experiment. Or I'm going to drop kick it into the incoherent oblivion. So, what is an experiment? Or what constitutes an experiment? From Penn State University, there should be 3 categories of variables in every experiment: the dependent, independent, and controlled. Your dependent variable, or the effect, or the result, is the prediction. The independent variable, or the cause, that which is varied and manipulated by the scientist to produce the effect. And lastly, controlled variables. Variables that are held constant so as not to confound the test. So you see this constant. Constant variables are controlled variables. Controlled variables are constant variables. I hope that's clear. So we won't just use Penn State. Let's go to experimentation from explorable.com. They're a research organization. There are 3 important variables you have to remember when you're designing an experiment: the independent variable, the dependent variable, and controlled variable. That's probably not good enough. Let's go to the Globetards' alma mater, Wiki. Experiment from Wiki. An experiment is a procedure carried out to support, refute, or validate a hypothesis. Experiments provide insight into cause and effect by demonstrating what outcome occurs when a particular factor is manipulated. Gee, I wonder what particular factor they're talking about. I just don't know. Experiment from the Nature of Science and the Scientific Method from the Geological Society of America again. Once the hypothesis has been established, it is time to test it. The process of experimentation is what sets science apart from other disciplines. Boy, we heard that above, didn't we? Sciences distinguish itself from other forms of explanation because of what? Well, because of experiment. And it leads to discoveries every day. An experiment is designed to prove or disprove the hypothesis. If your prediction is correct, you will not be able to reject the hypothesis. See this statement right here. How many times have we heard crayon munchers come in and say, science doesn't prove things? Really? Then why does it say prove or disprove? I don't know. I know what it is. These guys are wrong and the crayon munchers are right. Scientific hypothesis. What is it? A scientific hypothesis is your experiment statement. It expresses a testable proposed cause and effect relationship, the phenomena that was observed in step one. From nature.com, California Institute of Technology physicist Sean Carroll, he's one of the highest priests of the pseudoscience religion these days, arguing in the edge that hypotheses aren't simply useful tools in some potentially outmoded vision of science. They are the whole point. From the University of Rochester Physics Department, again, the scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. From Colorado State University, a scientific hypothesis, a special kind of prediction that forecasts how the independent variable will affect the dependent variable. From Lowell C. Cambridge University Press, a scientific hypothesis is based on cause and effect reasoning. A scientific hypothesis does not merely state X and Y may be related. I wonder what that X and Y might be. Do you think possibly it could be the independent and dependent variables? I don't know. He is being real tricksy by not mentioning it. A scientific hypothesis does not merely state X and Y may be related, but explains why they are related. From Drexel University, the scientific method is hypothesis-driven. One makes an educated guess to explain a cause-effect relationship. Again, from the Nature of Science and the Scientific Method, the Geological Society of America hypothesis. The hypothesis should also contain a prediction about its verifiability. For example, if the hypothesis is true, then 1 should happen when 2 is manipulated. Uh-oh. The first blank, number 1, is the dependent variable. Oh, it looks like we were on board with the last one. We guessed correctly. Let's see, that's 50%. It depends on what you are doing in the second blank. And in the second blank is the independent variable. It's all that we're right. You know, the independent variable, the one you manipulate to get a reaction. There should be no other variables in the experiment that may affect the dependent variable. Shouldn't be any questions about this. So, what are independent variables? Well, from Penn State, it is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable. From Colorado State, the independent, they put it in parentheses, the manipulated variable. Uh-oh. The variable that is changed by who? The scientist. It's what the investigator is testing. From Physics About, the two main variables in an experiment are the independent and dependent variable. An independent variable is a variable that is changed or controlled. Uh-oh. See, they got a little lazy with their verbiage right here. That'll mix some people up. So just stick with changed. Okay? An independent variable is the variable that is changed in a scientific experiment to test the effects on a dependent variable. From the University of North Carolina, in an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. An independent variable is the presumed cause, right? Whereas the dependent variable is the presumed effect. The IV is the antecedent, whereas the DV, dependent variable, is the consequent. It's an antecedent consequent type of thing. And bringing that up before I move on. This is something I was eating breakfast this morning. I was listening to the show, and people have been saying, and rightfully so, is how can you have gas pressure without a container? I've been preaching this for about 3 years, but on here for about the last, I would say, 2 or 3 months, right? And everyone, even all the flat earthers, have caught on to this, right? And they now agree that it's impossible to have gas pressure without a container. Pretty wise move. In the next breath, these same people then say, where is proof of the dome? Now, does that make any sense? Can somebody tell me, does that make any sense? Right? If you say that you must have a container to have gas pressure, then I don't know, what's the proof of the container in our closed system? Well, wouldn't it be the air pressure? Right? So my proof of a dome or a barrier is air pressure. It's this little necessary antecedent consequent game here, right? Now, if you don't understand this, stop snorting the fluoride or move away from underneath the power lines, right? Get away from them. Or pay your slobber nurse some overtime and stop being a tightwad. I can't believe that I'm hearing this from people right in the next breath. I don't know. I can't explain this. Are you not thinking? You're just spouting it off that you want to hear yourself talk. You're not reasoning, right? My word, people. Sorry about that. Okay, remember, viable independent variables must satisfy 3 criterion to be an independent variable. Number 1, it's your presumed cause. Number 2, the researcher must be able to vary and manipulate it. Number 3, the independent variable must demonstrably exist before you can use it in an experiment. All 3 criterion must be satisfied, not just one.
Now, sorry, just before you move on, can you just read the last one again and give a few examples that don't meet that criteria?
Yes. I'll read it over again. The independent variable must demonstrably exist before you use it in an experiment. Now, to keep it in context, most globetards start off with their hypothesis, which it isn't a hypothesis, and they get stuck because of it. Because what did they do? If the Earth is a sphere, right, is their independent variable. So, but they haven't proved that yet. That's what they're attempting to prove. Moreover, if the Earth is a sphere, you can't manipulate physically the spherical Earth. Unless you have special Evo mind powers or some type of fairy tale telekinesis or something, I don't know. You're gonna have to show me that. So that's typical one right there. Is that good?
Perfect.
So, like I said, all 3 criterion must be satisfied, not just one. So the next canard, like I was saying, this has come up sporadically. I mean, every now and again it'll come up because people just don't know what they're talking about. So let's go over it and explain it. Height or depth, width, length, and time are not viable independent variables. Examples. Number 1, the submarine was crushed at a depth of 10,000 feet. Did depth cause the sub to implode, or was it pressure? Number 2, the gentleman was so obese he measured 1 meter wide. Did width cause the obesity, or was it laziness combined with excessive calories? Number 3, over the course of the night, the sun suddenly appeared above the horizon. Did time cause the sun to appear above the horizon? In that same vein, does time cause the difference of scores between the first and third quarters? You see how silly these are? So please, please come in and tell us that distance, depth, width, height, time. Please come in and tell us and say they're valid independent variables. I want you to, please. The null hypothesis from California State University. To do a hypothesis test, that is experiment, you will actually have two hypotheses, the null hypothesis and the alternative hypothesis, which are stated in such a way that they are mutually exclusive. That is, you can't have both hypotheses be true. The null hypothesis is the conclusion that is considered the default. You will accept this hypothesis if you fail to find sufficient support for the alternative hypothesis. Makes sense. We'll go over one here in a couple seconds. The null hypothesis again from sciencenote.org. Null hypothesis, the zero difference or no difference, i.e. that means null hypothesis, predicts that changing one variable, the independent variable, will have no effect on the variable being measured, the dependent variable. So, like I said, the alternative and null hypothesis are stated in such a way that they are mutually exclusive. Both can't be true. That's what mutually exclusive means. So let's go through an example. It's a simple example. I've been using this for years. I think it relays the point quite succinctly. Observe a phenomenon. Healthy type 1 diabetics suffer from diabetic ketoacidosis, apparently from the absence of adequate insulin, right? That's what we observe. We don't know for sure yet, but it's an educated guess. So we make it a hypothesis, the alternative. Given otherwise healthy type 1 diabetes patients, the lack of insulin will lead to diabetic ketoacidosis. Conversely, the null is the mirror of the alternative. The only difference is will not. Null hypothesis, given otherwise healthy type 1 diabetes patients, the lack of insulin will not lead to diabetic ketoacidosis. This is null. The null result, null, zero difference, no difference. You get it? It's the mirror. It's all it is, just will not. It's as simple as that, right? And as you can see from our alternative hypothesis, if we go ahead and test this, and the lack of insulin does lead to diabetic ketoacidosis, that is, the patients get diabetic ketoacidosis, it ipso facto rejects this. See how that works? Now, the dependent variable in this, or in the alternative hypothesis, or the effect, the prediction is, of course, diabetic ketoacidosis, and the independent variable, or the cause of the effect, the cause of it is insulin, or the lack of. This is cut and dry, very easy. This is a valid scientific hypothesis, alternative. This is a valid null. These are valid dependent and independent variables. We observed a natural phenomenon. This is AAA plus scientifically valid, A through Z. So, in conclusion, pull this up here a little bit. In conclusion, you have the alternative, the null, and your experiment, right? So with the alternative, you have the independent variable plus the dependent variable. That equals a prediction of cause and effect. The null hypothesis is the same independent variable, dependent variable equals the prediction of no cause and effect. And then the experiment, the independent variable plus the dependent variable plus what? Controlled variables equals prediction of cause and effect. So the only difference between your hypothesis, your alternative, and the experiment is the controlled variables that you put in to keep it constant so it doesn't have any effect here. That's the only difference between these two. Everyone understand that? Hopefully. This is very important. From the University of Rochester Physics Department. Common mistakes in applying the scientific method. The most fundamental error is to make the hypothesis for an explanation of a phenomenon without performing experimental tests, right? This is the most fundamental error. But what do we get? We don't even get this part, right? We just get this. We just get an explanation. Now, if you need both and it's still a fundamental error, what would just be getting one be? Right? They can't give us a hypothesis. Well, for number one, they don't know what hypotheses are. Even if they did, they can't give us one, right? Because the whole inquiry is non sequitur, but they don't know that, right? So we don't need this. Anyone can give this. Your average village idiot can give this. We don't care. If you give us an explanation, we want it accompanied by a hypothesis, this guy, beforehand, and then afterwards, we want to see this guy. Is this clear? Right? Crystal, right? Yeah, watch the show tomorrow. Watch what they do. Math. Mathematics isn't science or physics, much like a tape measure isn't carpentry. One of the main reasons is they're different words. From Professor Balakrishnan from ITT Madras. That's the whole point about physics. It's not mathematics. Duh. So it's not a set of axioms from which you derive results. The rules of the game you prepare to change and subsume an even broader framework. So let's read this one more time. Just the top part. That's the whole point about physics. It's not mathematics. Why are people coming on the show and telling us that mathematics is science or physics? You're standing in direct contradiction of this fine professor here, aren't you, crayon munchers? But you'll continue to do it. From the chair of physics at Yale, quantum mechanics, it's a theory which is based on experiment. It's not deduced by mathematics, right? Do you see the juxtaposition here between experiment, right, and mathematics? There's a juxtaposition there. They're two different things. Maths don't prove reality. For example, 1 apple minus 6 apples equals negative 5 apples. Well, can you show us negative 5 apples, friend?
I've heard different, though. I've heard that math is reality.
Is that what you heard?
That's what I heard.
Was that Mystic Meg?
No, I read rhetoric.
That's Mystic Meg. Yeah, we're talking about the same thing. This is one of my favorites. Give us the equation for germ theory, right? Because if they say that science is mathematics, well, this is actual science. And to support their statement, then therefore, there must be an equation for germ theory. Post it, please. I want to see it. You'd have better chances resurrecting Alexander the Great's horse than providing an equation of germ theory. Clowns. Math is immaterial and abstract, rigidly domain specific, and at best merely describes. It explains exactly squat, nada, niente. Conversely, actual scientists are in the business of explaining phenomena by validating or invalidating cause and effect relationships between independent and dependent variables via rigorous hypothesis testing. Can you show one case in all of history where mathematics caused any phenomenon? Can you show the laws of motion, which are equations, causing a billiard ball to roll across this table? Do you see how non sequitur all this stuff is? Right? It's non sequitur fallacies everywhere. It's like a potpourri of non sequitur fallacies. I love it. Keep bringing it up. I got the nail spiked 44-inch Louisville Slugger waiting for you. Models, one of our favorites. Now, when you say models, do you mean this type of model, or is it this type of model? I mean, you say models, but you don't tell us which one it is. You don't quantify or qualify. Got something for you. From the University of Indiana, listen closely. The important point that Becker, and just to let you know, this is Johann Becker. He is known as basically the father of phlogiston theory. Introduced The important point that Becker introduced is that the explanation of a natural phenomena, i.e. a model or theory, see now they're equivocating, this isn't even an equivocation fallacy, a model, they're treating a theory like a model, I have no idea why, must be testable by experimentation. Listen up. In other words, once a model is proposed as an explanation of a phenomena, it can only be considered a scientific model if it can be objectively tested by experimentation. So you have a scientific model, do you? Okie dokie. Natural phenomena observed, please. Alternative hypothesis, please. Independent and dependent variables, please. And give us the null hypothesis. You're done. Finished. Bring that model back in here. Bring it in here. Another canard, scientific predictions. Scientific predictions are not Gene Dixon, Edgar Cayce, Jimmy the Greek, Mystic Meg, Nostradamus, or Carnival tent predictions. Again, words have precise meanings in science. What is a prediction? In fact, what is a scientific prediction? Because we're needing a precise meaning of prediction. Not a carnival tent prediction, right? What is it? Uh-oh. A scientific hypothesis, a special kind of prediction that forecasts how the independent variable will affect the dependent variable. So when you come in here and say, but we can predict, guess what we're going to say? Natural phenomena observed, please. Alternative hypothesis. Your prediction. Get ready. Yeah, you all be ready, right? Uh-huh. From Penn State University, the scientist applies his or her present knowledge to predict the effect of the independent variable on the dependent variable. The prediction is a statement of the expected results of the experiment based on what? The hypothesis. The prediction is often, not always, an if and then statement. So, to have a scientific prediction, you must have an independent variable and a dependent variable. In other words, a viable scientific hypothesis. Any questions?
I'm good.
I figured you are. All right, this is going to be loads of fun right here. You thought the upper part was bad. Boy, they're going to be a hurt locker after this one. Okay. We're going to juxtapose scientific laws and scientific theory. Go through this step by step because I don't think I ever did this before. Maybe off the cuff, not explained it completely, so I'm going to go slow. So, scientific theories. They explain the how and the why, the mechanism and the process, and they identify the cause. For example, germ theory. Scientific theories are the result of validated, confirmed scientific hypotheses that have been rigorously tested. That is, to have a scientific theory, it must first go through the gauntlet of the scientific method and be validated. Otherwise, it's not a scientific theory. It has to be tested first and confirmed. Then you have a scientific theory. So these, or real scientific theories, are birthed from the scientific method. Let's take a look at scientific laws. These describe the what's and the is's, and we went over the definition of above from Kennesaw State. They describe the what's and the is's. The cause is not applicable. Uh-oh. If the sole purpose of the scientific method is to identify the cause or cause and effect relationship, and scientific laws, the cause is not applicable, do we have a problem in Shangri-La? Hopefully you're catching on to this. I'm going to bring it on home here over the next few minutes. These scientific laws that they call scientific, they are based solely on observations. They're often expressed mathematically, like the second law of thermodynamics. You see, with scientific laws, the cause or the how and why or the mechanism are both nonsensical and invalid inquiries. It's just an is and an are. For example, how or why does heat flow from hot to cold always? Well, I don't know, and we'll never know. All we know every single time, it just does, and it is. It's a what and an is. Therefore, scientific law. That's why they're called the laws of thermodynamics and not the theories of thermodynamics. Does everyone understand this? Hopefully, if you don't, go back and rewind it. Scientific laws never, ever become scientific theories, or vice versa. Each are domain specific inherently. Right? So, and scientific theories never, ever explain laws. I'm talking real scientific theories. They never, ever explain real scientific laws. Because if they did, then it wouldn't be a law anymore. So when people say Einstein's theory of general relativity, which isn't an actual scientific theory to begin with, explains Newton's law, which isn't a law to begin with, they're pretender clown crayon munchers. Does everyone understand that? Hopefully.
Well, probably
so
not.
After,
but it'll come up again.
I'm sorry, go ahead.
I was just going to say, you said everyone getting that bit. Probably not.
Yeah, I'm sorry, it was a rhetorical question. All right. So after stating the above, all the above here, what should be your next question? What should be your next question? I won't reveal for a couple seconds. I need a drink. Go ahead and think about it on your own. So what should be your next question after everything that we went over above? Let me reveal it. What makes the laws of physics scientific? Oh boy, the tangled webs they weave. Scientific laws, that is, the laws of physics, are not scientific. They're merely descriptions. Oh, here's the important part, as evidenced by, okay? As evidenced by. They are merely descriptions, often expressed mathematically, of plain old observations of nature. That's all they are. The scientific method, on the other hand, is only employed to elucidate and explain cause and effect relationships, the hows and the whys, not describe the what's and the is's. Scientific laws only breach the first step of the scientific method, observe a phenomenon. You can't formulate a scientific hypothesis, step 3 of the scientific method, because a viable cause, independent variable, doesn't and never will exist. Forever illusory. This is quite interesting. I'm loving every bit of this. So, Professor Tegmark he's a professor of physics at MIT. Let's hear what he has to say. We humans have gradually discovered many additional recurring shapes and patterns in nature, involving not only motion and gravity, but also areas as disparate as electricity, magnetism, light, heat, chemistry, radioactivity, and subatomic particles. These patterns are summarized by what we call our laws of physics. Continuing, Professor Tegmark, when we look at reality through the equations of physics, I'm going to let that go. We find that they describe patterns and regularities. Is this science? But wait a second, my son is a video game master champion. He can readily recognize and describe the recurring patterns and regularities present in the game, all the while being absolutely clueless about the underlying architecture of the game. But he intuitively knows that the patterns and the regularities in the game, watch out now, are not the cause of the game. Right? Hello? And is my 10-year-old a scientist? 2, how can the laws of physics, that is, descriptions of patterns and regularities in nature via equations, have anything whatsoever to do with the scientific method, science? When the scientific method is solely based on hypothesis testing, which is only employed to explain cause and effect relationships, the hows and the whys. Describing focuses solely on whys and hows. Describing focuses solely on the whats and the ises, and explanations focus solely on the whys and the hows. That's the difference, right? There's a big difference between describing something and explaining cause and effect relationships, right? Like actual hypothesis testing, i.e. experiments. Watching heat flow from hot to cold, or gases flowing from high pressure to low pressure, isn't an experiment. It's merely observing a phenomenon. And again, have the laws of motion ever caused a single billiard ball to move across the table? The story begins and ends at the first step of the scientific method for those laws, right? Is that science? Nope. Well, we can predict, right? That's what we hear. So, after observing heat flow from hot to cold a few billion times, the second law of thermodynamics, without fail for a few thousand years, you scientifically predict, amen, and genuflect, that if I set my scalding hot cup of coffee on the table for 20 minutes, it's going to get cooler? Wow, a seer. Thanks, Captain Obvious. You must be a scientist. A complete moron at the beginning of time could have reached the same conclusion in a coma. Crocheting is more scientific than the scientific laws. They just throw the term scientific in front of the word law by mere fiat without any warrant whatsoever. Say again? Did you say something?
I didn't know. I was on mute too.
Okay. Yeah, I got a lot of feedback. Okay, let me go over this one more time. Crocheting is more scientific than scientific laws. They just throw the term scientific in front of the word law by mere fiat. Like I said, without any warrant whatsoever. It's a beach ball squirrel scenario. See, I just placed this beach ball in front of the squirrel, right? By fiat. Does it make any sense? Well, maybe to some people. Then what do? Since heat flows from hot to cold always, they describe it using equations. Then pronounce from the rooftops that this is a scientific law. Amen. Science. Then, when Joe Coffee and Betty Breadmaker come along and experience every single time that their scalding hot cup of coffee cools down in 20 minutes without fail, they then conclude, well, these scientists are sharp. They really know what they're talking about. This is second grade slick. It then greases the skids for their propaganda efforts with Joe Coffey and Betty Breadmaker, i.e., the masses of scientific illiterate public, to now put the term scientific in front of just about anything for veracity and validation, right? That's what they do. Here's what we got, right? That's what they got. Evolution, Big Bangs, multiverses. They got this out of a 1940s comic book. Black holes, gravy waves, I call them. Dark matter, spinning balls. You see the game here, people? It's just linguistic acrobat. It's not even acrobatics. They just put the word in front of it, right? And then they superimpose that so other things have more veracity somehow, right? It's a little child's game. This is a joke. In conclusion, file 13, the term scientific with laws, as a tear-jerking belly laugher, it's incoherent and nonsensical. It's a misnomer. The scientific, just remove the scientific part. You're good. They're just laws. And what are they? Natural laws. I'm not saying that the natural laws are false. I'm not saying, that's not what I'm saying. The laws are true. They're just not scientific. Duh. Hopefully everyone got that. There's a few nuances in there. I'm sure there's a lot of panties getting in bunches now.
Oh, absolutely.
Did I do that? Did it sound good? Did you understand that? Because we never talked about this.
Oh, yeah, but it's triggered a few people in the chat, and I was chatting along while it was... I know we haven't, that's why it was sparking my interest to discuss it in the chat while you were discussing it on screen, because I didn't want to interrupt. But yeah, brilliant.
Right. Well, hopefully people will go back and review everything I went over, and it's all true. It all lines up, it all makes sense, right? You can't refute this. It's impossible. Okay, let's finish up with a couple canards that we're getting recently. And this one, explanations. This is one of my favorites. Okay, anyone that treads into this genre for more than 30 minutes, you will invariably be challenged to provide your explanation. No matter that you haven't made any claims yet, right? Right? We get it all the time on the show. He'll cut right out of the blue. Well, can you explain, just make, it could be anything, right? What's a good one? Explain what? Explain equatorial mounts, right? I'm saying, what the heck? And we didn't get a chance to go through his scientific experiment for that. I can't wait for that. We need to get him back on. But anyway, I digress. So this is one that I personally got the other day. I get them constantly too. This one right here, right? Can you explain a bowling ball falling at that pesky 9.8 meters per second? Right? This is what I wrote back. See if you like this. This is for you flat earthers. You can use these. They ain't copyrighted. Right? Number one, this nonsensical buffoonery already assumes, right, that my explanation is somehow up against some unspoken true explanation from the querier, right? Number two, I don't need to provide my just so story explanation to pummel your unspoken just so story explanation. Number three, I highlighted this one because this sends them off the reservation. Do you wander around aimlessly asking complete strangers for their explanations for which they haven't made any claims for or against? Are you clinically insane? Right? That sends them right off the edge. It's so true. Number four, what's your explanation? Since you seem to have one. And Crayon Muncher, I'm going to need validated experimental support accompanying your explanation, because without it, it's codswallop horse puppy bollocks, right? We went over that above. We don't need an explanation. We need a hypothesis, right? Then the explanation, and then the experiment. That's what we need, not your just so story fairy tale explanation that you're parroting from the wiki pseudoscience priests. And let's finish up with the last one. And like I said, the second day that I get into this, and it's not only specific with in the flat Earth realm, no doubt about it. This has been going on for millennia, I guess, for as long as science has been around. Science says, well, folks, science is a method, the scientific method. To have the ability to say, one must have sentience, prescience, and intelligence, aerobic respiration, lungs, vocal cords, and a tongue, essentially to be alive. Science isn't alive, therefore, it's a reification fallacy. Additionally, just for your information, science doesn't have community, stand for, make mistakes, then correct itself, run, jump, swim, promenade, and bow to its partner across the hall, or do the hokey pokey. People do such things, not concepts or methods. Thanks for your ear. Have a nice day.
But just before you do round out, sorry, John, can you go back up to point 2? Just before science says.
Point 2 for science says. This one?
About having a just so story.
Oh, that's for the explanation.
In essence, loads of people fall into this trap. So, what's your model? Yeah? And often people have got a model because they've been presented with something like an azimuthal equidistant projection. So we're talking flat Earth versus globe Earth. And if you've got an azimuthal equidistant projection, you've got an answer for them, right? Well, no, you don't need to give a just so story to pummel the living daylights out of someone else's just so story. You can just pull it apart at the seams. You don't have to present a just so story of your own. You don't have to make up an explanation for some nonsense. No need. Just pummel their explanation.
I agree. And remember, they don't have a model either, right? Because we just went over models. If they're going to provide a scientific model, now that's a different story. They can have models all they want. You know, bring in any type of model, the airplane model or you know, the runway model. But if they say scientific model, they got a big problem, right? Because they're going to get the treatment. And what's that treatment? Natural phenomena observed, please. Alternative hypothesis, please. Independent, dependent variable. No hypothesis, you ain't getting away, right? Because this is your huckleberry right here. No more equivocating with this word model. No more mindlessly parroting from Wiki models this and models that. Because we're going to put you in the corner and say, do you have a scientific model? And the moment you say that, you're done. You better have a hypothesis coming out of your mouth next. I'm sorry. You better have a natural phenomena observed coming out of your pie hole next. Or we're going to go nuclear.
Indeed, but once again, you don't have to actually have your own nonsense story on top of that. So that, again, is a trap people fall into. You pick apart someone's total nonsense, and then their comeback as they're falling to the canvas, their punch on the nose is, well, what's your explanation? And suddenly people feel obliged to come up with some nonsense on the spot, or repeat some other nonsense someone else gave them as a just so story explanation that works on some model or map that they've been given that may or may not be the world that we live in.
That's correct. I don't see people. It doesn't even make sense, right? Would you go up? Just try this. When you're out getting petrol or going shopping, just go up to a complete stranger and ask them to explain something. Just try it. Tell us what happens. Please, somebody video that. Right? It's friggin' inane. No one would ever do that. They might get punched in the face depending on what they're asking for the explanation for. Right? It's just stupid. I don't know where they got that from. I really don't. It doesn't matter.
I didn't run this by you before the show started, but do you fancy taking a few questions from the chat? If not, we'll round out now.
No, I don't mind.
Okay, this is your moment, chatters.
They're coherent.
Let's see if I can do justice to anybody's questions. So Nick got timed out for asking the same question about 50 times. Let's see if he actually asks it now.
Nick.
Nick L. Nick
Okay,
Noel.
I don't. No, I'm not answering anything from that crayon muncher.
Okay, it might be the case that we ran out. We'll see. We'll give it a minute or two.
Just ask your slobber nurse, Nick. Okay,
We'll see.
that's why you employ her.
I'll give it a minute or two if there's anything that comes through while.
Yeah, that's fine. Take your time. Yeah, I got like 10, 15 minutes, man. I'm good. No hurry.
Yeah, good presentation. I know it's been a pain in the bum to put together.
Technically, it was a pain in the butt. Like I said, I had some problems with the with Gmail and stuff, deleting presentations. I tried to remain calm during the presentation. That sometimes doesn't work with me because I sometimes I lose it. But I tried to remain calm here. Yesterday, when I was putting together, I got really agitated that I would even have to go over some of this stuff, right? Because as you can see, when I go through some of the explanations on the various topics or the subtopics, this stuff is really simple, right? I mean, there's some nuances to certain things you have to go and find the answers for, but for the most part, I mean, this stuff's pretty easy, right? After about 30 times of me saying it, you should get it. And that's why I said at the beginning, and I'm just talking to the flat earthers here, and let me just reiterate this. The gloves are off. I don't care who you are. If you come out here vomiting from your incoherent pie hole, your verbal diarrhea, I am going to embarrass you, right? And I think I'm justified after 3 years. I'm just not going to put up with it anymore. You're not representing the truth or your position at all. All you're doing is you want to listen to yourself talk and stuff. Well, like I said, go find cake decorating platforms or whose favorite color is the best platforms and go ply your wares there.
Right, I think we've got a candidate for a first question. At Quantum Eraser, don't know how coherent this will be. If what you require of scientific model is to be part of the, quote, natural world, end quote, then what about quantum mechanics?
Number one, it's not my requirement for a model. Let's go back up here. Let's see if I put this, let's see if it's a citation by Quantum Eraser. Right? That's the first part of the question. This is Indiana University. I have never attended Indiana University chemistry department. Just so you know, I did not write this. This is not my writing. I have put it in quotations, appropriate citation. This is not from me, so it's not my problem. Second part of that. Second part of that question, please.
Well, it kind of doesn't tie into the first. What about quantum mechanics? Question mark.
What about? Go ahead and read the full question again, please.
Let's just scroll up and find it. Bear with me.
Oh, I thought you had it. I'm sorry.
It's okay. I'll find it, I'm sure. Or maybe not.
I think where they were going to I think they were going to something that old Rufy brought up a long time ago, and I think they're hung up on this natural phenomena and quantum mechanics. Well, the natural phenomena observed in quantum mechanics are photons. Photons come from the natural world, along with electrons, protons, and neutrons. Right? There are no models.
Okay, I'll read it again. I think further down there's a supplementary question. So it's from LAHBRECA at Quantum Eraser. If what you require of a scientific model is to be part of the quote unquote natural world, then what about quantum mechanics? Question mark.
Yeah, what about it? Yeah, that's the natural world. Quantum mechanics deals with the natural world. Now, the technologies that spin out of quantum mechanics having to do with photons, electrons, doping chips, and such, that's technology. That's fine. It's just different. However, but the science and the scientific method used to elucidate or afford the ability to use that in technology there's nothing wrong there. Everything's okay.
Okay, I'm not going to
right?
tell you who this question's from. Why
Okay.
an quote if dot 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 then dot 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 end quote statement at John? Why no other types of hypothesis? Question mark. That's from
Oh,
Nick.
that's that crayon muncher Nick L. This friggin' moron thinks that formal scientific hypotheses are only those hypotheses with that have if and then in them. I mean, I, it's absolutely mind-numbing to me,
Well,
right?
well,
That's his.
what's the
That's
answer?
what it,
Why does it have to be a formal hypothesis?
a formal hypothesis. Well, we have to define what a formal hypothesis is. A formal scientific hypothesis contains an independent and dependent variable. Nothing to do with how the sentence structure is stated, right? So all it has, let's go back up to my hypothesis up here. Let's see, did I use an if and then with that? Let's just check. Scientific hypotheses should be getting close. Okay. Uh-oh. I don't see any if in here. Do you? Given otherwise healthy type 1 diabetes patients, the lack of insulin will lead, not even a then. I don't have an if and then statement in here. Uh-oh, call the police. Right? Let's go back up here and let's just pulverize this into the incoherent oblivion once and for all. I think I got it here. Hypothesis, scientific hypothesis. Give me a moment. Where'd you go? I think it's from Penn State. Where'd you go, brother? Doesn't fix scientific hypothesis, point.
There's a few more reasonable questions. I don't know how much time you've got.
1 second, let me before you ask them, just hold on for a second. Let me see if I can locate this. I know I already pummeled it, but let's just make sure and I'll pummel it officially. I think I'm just missing it. Fiction. It has to do with his train wreck appeal to if and then, which is, it's so moronic, so petty. And I think I just stated it. I think I just went over this. Oh, here it is. We finally found it. Okay. Here we go. From Penn State University. The scientist applies his or her present knowledge to predict the effect of the independent variable on the dependent variable. The prediction is a statement of the expected results of the experiment based on the hypothesis. Can everyone see this last statement here? What's that say? The prediction is often an if and then statement, crayon muncher, not always. My word. Go on, Nathan.
Okay, so I've got Jimbo who says, is mass a constant and weight a variable unit?
He has to define mass first. I have yet to hear a definition of mass in 12 years. It's like evolution. You'll never get it.
Okay, well, if I get to one, if he qualifies that further down, I'll ask.
Sure.
Who else we got? QE says scientific model has to study the natural world, which does not include humans. How about quantum mechanics? It was developed in the lab, not in the natural world.
Developed in what is the natural phenomenon that's observed that led to quantum mechanics, son?
Photons.
Are they natural?
Yeah.
Or does man make them?
They're natural.
How about electrons, protons, neutrons, molecules, atoms?
None are man-made, as far as I'm aware.
Yeah. Next.
So Nick re-asking the same question. Why do you
No,
assume the type of hypothesis has to be if and then statement? Come on, John. I think you've just covered that. Any more for any more?
I must have explained that to him greater than 10 or 15 times. His juvenile moronic appeal in comment section. He just keeps on asking the same question. You haven't answered it. Call him eraser. No. You're a poopy pants. Right? That's all I get.
Hand wave dismissal, right?
Yeah, they just appeal to nonsensical buffoonery. That's all they can do. And it just shows you the absolute bankruptcy of their position.
Okay, I'll try and read out this question from Gleam. At Quantum Eraser, on the, quote, using only the natural world, end quote. If we analyse electric as seen in lightning, how do you hypothesize and experiment on the field without voltmeters?
The voltmeter is not the natural phenomena observed.
Right.
Electricity is the natural phenomena observed.
Yeah, I had Tim Osman with this. So Tim Osman was saying, how can we possibly do experiments if you're saying you can't use man-made stuff? And it's like, no. We're talking about the natural world. And that specific thing that we're observing happening is happening in the natural world. That's why we're interested in it if we're doing science. So it's not that you can't have equipment. It's that the dependent variable, your observed phenomena, takes place in the natural world. Right?
Yeah. What is, they have the wrong emphasis on the wrong syllable. We're talking the natural world, the natural phenomena. Step one has to be natural. The phenomena itself, not anything else not anything else in the experiment. In the experiment, you have to use man-made stuff, right? But that we're not trying to identify the cause and effect of that man-made stuff. We're trying to identify the cause and effect of this guy.
Got time for a few more?
Yeah.
I don't know if this is Dan trying to cleverly tie this into exactly what you've just said, but from Dan W. What did science ever give quantum eraser? Question mark. Mobile phones, computers, or microwaves?
Yeah, quantum mechanics. Yeah, it's especially the high-tech varieties of today, quantum mechanics. The technology derived from scientific experiments. The technology isn't science.
Hold on. Well, hold the phone. No. If I use my mobile phone, that ipso facto makes me a scientist because my scientist has come from scientific discovery. That's correct. That makes me a scientist. Same if I use a microwave. I'm using science, therefore I'm a scientist, aren't I? I cook something in a microwave, I'm doing science.
Unbelievable, man.
Is that not correct? Oh, am I kidding myself? Surely I'm a scientist when I use a microwave, right? It's come from science. That makes me a scientist, doesn't it?
Wow. I think maybe volunteering for drug testing is in their near future.
Yeah. So, just to make it clear, using technology that may have derived from scientific discovery does not make one a scientist. See if there's any more questions. If not, we'll round out. Mostly debates going on in the chat, which is nice to see. Is that a response from Jimbo? Those are conditionals. Not sure if that's in reply to your comment or your response to his question. Sorry.
If you're gonna ask a question about mass, then you have to demonstrate the knowledge of what it is. So define mass. It's a very simple question.
So his question is mass a constant and weight a variable unit? I'm just seeing if if any further down he's actually addressed it, because he'll get really annoyed if I don't actually find his follow-up answer and then we round out. I'm searching. You'll be the last one, I promise. Jimbo says mass. Yeah, what is mass, Jimbo? Let's see. So much chat. So much chat. massive shout out to all the audience. Thank you so much for tuning in. I will give you a proper thank you as I round out, but if we can get to Jimbo's question. One definition of mass given.
One. So there's multiple definitions of it, right? Define equivocation fallacy.
You've got 60 seconds, Jimbo, and I'm pretty sure my delay is only 2 seconds between me saying this and you hearing it. So you've got about a minute to... Here we go. Mass is all through experiment and calculations. Yeah, that's not really defining mass. Sorry, Jimbo. Might not get your question through. One last chance. Got about 20 seconds. Then I'm going to be rounding out. Be honest, I think I'm clutching at straws thinking that Jimbo's going to give a really top quality definition for mass. We'll see. You never know your luck. No, I don't think so. Anything you want to add? If not, I'm going to round out, John.
No. Any questions from you? We talked about a couple new topics here that we personally didn't go over before. We talked about models, right? They're done. They're finished. If they come in and say they have a model, your retort is that a scientific model? They have to say yes. So what do? Natural phenomenon observed, please. Yeah.
I mean, I've only got one question, which is, it's not really a question. It's kind of echoing the sentiments of the chat throughout the show. So I think the only person who actually said it prior to you getting to your crescendo was Flat Earth Reset, believe it or not. So he was pointing out that scientific laws are not science. And you got to your crescendo while he was saying that in the chat. And you were saying they are natural laws. Now, simultaneously, you've got Nick in the chat going, well, this means that the second law of thermodynamics isn't science, it's pseudoscience. So how would you address that?
No, it's not. It's just the second law of thermodynamics is true. Just like all the laws of thermodynamics are true. They're just not scientific. That's all.
Well, I've been using the term fact of life, and what I'll call it now is a law of nature, which is a better description than a fact of life. The fact that you have a description for it's like, well, my response to Nick in the chat was, well, good luck falsifying the second law of thermodynamics. If you want to deny entropy because you want to believe you live on a spinning space ball in a vacuum, then that's up to you. You know, these things are, as I would have put it, fact of life, but a law of nature.
Yeah, and listen, this pseudoscience stuff, it only becomes pseudoscience when the person propagating or claiming it is portraying it as science, right? Then it's in that context, it's pseudoscience, right? But in the overall context, it's not pseudoscience. It's just it doesn't pertain to science. You following me with that?
Not exactly. Say that one more time, maybe rephrase it slightly.
Yeah, for something to be pseudoscience, it has to be masquerading as science. If it's not masquerading as science, it doesn't make it true or false or whatever.
I understand. Right? So when you have Neil deGrasse Tyson saying, paraphrasing what he said, words to the effect of, it doesn't matter if you like it or not, science is real. Now, he is an astrophysicist. So he is a pseudoscientist because he's masquerading as something that could be defined within the boundaries of science, establishing cause and effect. And all he can do is observe phenomena all day long.
And provide just so stories and masquerade those just so stories as science, right? That is pseudoscience. Now, microwaves aren't pseudoscience unless you're trying to say that microwaves are science. You see what you understand?
So when I claimed that I was a scientist because I'm using a mobile phone or a microwave, that makes my claim to cooking something being science, pseudoscience, a pseudoscience claim. And me, a pseudoscientist, by claiming that using a microwave born out of scientific discovery makes me a scientist, and anything I do with that microwave would be a scientific discovery. No, that's pseudoscience. Whereas
Exactly.
claiming a fact of life or a natural law isn't pseudoscience, it's just a natural law. It's how it is.
Exactly, you got it. Exactly.
Okay.
Precisely.
That makes sense. Brilliant stuff. Well, it's been an absolute pleasure, John. I don't know if there's any last thoughts you want to add, but I will definitely round out after them if you do.
No, I don't. I think I said all I needed to say. I hope some people got a lot out of it. Maybe some things that they didn't know, and maybe it'll connect the dots for them a little bit. That's my hope here. And to my ultimate goal is for flat earthers to use these to expose crayon munching pretender clown globetards. That's the goal.
Excellent. Well, with that, I'll say first and foremost a massive, huge, enormous thank you to you, John, for joining us and explaining what science actually is. Thank you to you.
You're very welcome, sir.
And of course, a massive, huge, enormous thank you to all of the live audience for tuning in and hopefully sharing this discussion. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!